Hi, today we're looking at City & Guild's Functional Skills Maths Entry Level 3. This is the Floristry sample paper and we're going to start with the non-calculator section. Question 1. Subtract 490 from 842. So it's this word from is telling us we're starting with the 842. And then we're going to take away or subtract 490. So we're going to start off with our units. So we've got 2, take away 0. That's still going to leave us with 2. Then 4, take away 9. Well, 9's bigger, so we can't take 9 away from 4. So instead what we say is, well, we're going to take 1 from the 8. So that's going to reduce down to 7. And the 1 we can put up here to make this 14. So we've now got 14, take away 9. Okay, so we can count back from 14. So we've got 13, 12, 11, 10, 9, 8, 7, 6, 5. So that's counting back 9. Then we're left with 7, take away 4. So, we can do it this way. So we'll start with 7, take away 4. So 1, 2, 3, 4. That's left us with 3. Okay, so two slightly different ways of doing it there. And we end up with 352. Okay. If you want to check this one, what you can do is do the 352 and add back 490. And that will get you to 842 that you started with. Okay, question 2. What is the next number in the sequence? We've got 19, 38, 57, 76. One way of doing it is to look at what these numbers are increasing by each time. Now, without a calculator, it can be a little bit fiddly. If you can see it straight away, then that's fine. Instead, what we can do is kind of look at the tens and the units separately. So if we're looking at what's happening with the tens, 1 to 3, well, that's going up by 2. 3 to 5, it's going up by 2 again. 5 to 7, again, that's going up by 2. Now let's look at what the units are doing. 9 to 8, well, that's going down by 1. 8 to 7, it's going down again. 7 to 6, that's going down 1. So if our tens are going up by 2 each time, we're going to add on another 2. So 7, 8, 9, adding the 2 on, and we're reducing the units by 1. So 1 less than 6 is 5. So we've got 95. Okay. So if you want to work them out, you can do 38 take away 19, and you will find you've got a difference of 19. 57 take away 38, you'll have 19 again. But it's just a longer process, especially if you haven't got a calculator. So it's good to see if you can find a nice pattern like this to save you a bit of time. And question 3. Round £24.36 to the nearest 10p. Well, the 10p, well, the p's or the pence are going to be this 36 here. And the tens are the 3s. That's the 10 pence bit, or the tenths, if you think of it as decimals. So we have to look at the digit after that and say, is it 5 or more? Yes, it is. So we need to increase the 3 by 1. So that's going to make us £24.40. Or we can think of it as a number line. We've got £24.36 somewhere here on our number line. It's going to be between two numbers to the nearest 10p. Well, if we went down, we'd have £24.30 would be below it, and the 10p above it would be £24.40. So we're then saying, which one is it closer to? And again, if we're looking at 30 to 36, this is a difference of 6p. If we're looking at 36 to 40, That's only a difference of 4p, so it's closer to this one. Okay. On to question 4. What time does the clock show? Use AM or PM in your answer. Okay, well, we'll have a look at the clock face first. So, well, let's look at the little hand because it's going to be the hour hand. So I'm going to do this as a digital clock. So it's gone past the 5, so it's going to be 5 something. And I know that each of these sections is 5 minutes. So we've got 5, 10, 15, 20. So it's going to be 5:20, and it's the morning, so it's going to be AM. Okay. Question 5. Round 734 to the nearest 10. So another rounding question. So this is a little bit like before. So I'm going to go straight for a number line this time and say, well, what are the tens either side of 734? Well, if it's a 10, it's going to have 0 units because it's rounded to the nearest 10. So 0 units, we're going to have 730 is going to be down one end. The next 10 bigger than 730 is going to be 740. So we're then working out, is 734 closer to this number or this number? One nice way to do it is say, well, what would halfway between the two be? Well, that would be 735. 734 is going to be this side of it. So we're going to round down to 730. And that's our final answer. Or you can do like we did before and say, if that's 734, well, this difference here is going to be 4. And 734 to 740 is going to be 6. So again, this is going to be the closest one. Question 6 now. We've got work out 67 times 7. So a few different ways you can do the multiplication. I'm going to do it using the column method. So I'm lining up my units. So I'm going to start with the units and say what 7 times 7. So 7, 14, 21, 28, 35, 42, 49. That's 7. So 9, carry the 4. And don't worry if you're not quite as quick as me doing that there. You can take your time and you can just add on 7 each time. Do it as counting. Nothing wrong with that. So we've carried the 4 because this is the 40 of the 9 that we're not able to put down yet. Then we're doing 6 times 7. Well, we can start again, or we might be able to remember what we got up to before, but I'll do it from the beginning. So 6 times 7, 7, 14, 21, 28, 35, 42. Now we've got the 4 to add on. So from 42, we've got 43, 44, 45, 46. So put our 6 here and our 4 here. So our final answer is 469. Let's bring this down here. Now we've got question 7. Which of these is the highest number? Tick your answer. Okay, well, you might be able to spot it straight away. But we've got a different number of decimal places here. We've actually got the same whole number part at the beginning. Now what I'm going to do is I'm going to line them up. So I'm going to have 934.6, 934.18, 934.39, and 934.2. Now that might not feel like it's helping just yet. So let's give all the decimals the same number of decimal places. So if we've got nothing here, we can put a 0. Nothing here, we can put a 0. Now because the whole numbers are the same for all of these, we can actually cover them up. Because all we're interested, the only difference in the numbers is the decimal places. So we can even cover up the decimal point. And now instead of thinking of it as 934.6, we're just looking at 60, 18, 39 and 20. So which is the biggest of those numbers? Well, it's that one there. So we can tick that one. Okay, question 8. Let's see if we can fit the question on here fully. Yeah. A woman wants to mix some plant food. The pack says mix mix with 1 litre of water. Mark on the measuring jug how much water she needs. Well, this is really testing that we know how many millilitres there are in 1 litre. So not too much can do if you don't know. With conversions, especially metric conversions, so whether it's millilitres, metres, litres, kilometres, the conversion's always going to have zeros in it. So it's either going to be 10, 100 or 1,000. So if you don't know, guess. On here, the only hundreds, we've either got 100 or 1,000. Now, I do know that we've got 1,000 millilitres in 1 litre. So I can put an arrow on there. But as I say, if you can't remember all your conversions, just think, well, should I go with 1,000 or 100 or 10? Whatever feels most right to you. Right, question 9. A florist uses patterned paper to wrap flowers. He orders some rolls of paper. I've got gold dot paper, 263 rolls, and blue dot paper, 546 rolls. And he said that the total is 809 rolls. Now they're asking us to use approximation to check his total. So what they don't want is you to add up these individual numbers. Okay, because they're saying approximation. This is the key bit here. So, well, if we're going to approximate, that means we need to do some rounding. So we can choose what we round to. Well, we're either going to round to the nearest 10 or the nearest 100. I'll round to the nearest 10 with these. So I'm going to say to the nearest 10, well, the 10's the 6. Because we've got 60, so that's our tens. So we look at the number after it, which is a 3. It's less than 5, so we're going to round that down to 260. 546. Again, we're going to look at the tens. The tens, the 4. This time, the units are 6, so it's more than 5. So we're going to go up to the nearest 10. Which is going to be 550. So now we can do our addition. 0 plus 0 is 0. 6 plus 5 is 11. So 1 and carry the 1. 2 plus 5, we'll start with the bigger number 5. 6, 7. And then add on the extra 1. That's going to take us up to 8. 810. And that's approximately equal to 809. So that looks okay. If we wanted, we could round it, instead of to 10, we could round it to the nearest 100. So let's do that. So actually we could say, well, if we go back to the original number, 263, to the nearest 100, well, it's either going to be 200 or 300. The 10 is more than 5, so we'd round that up to 300. 546, we want hundreds, which is the 500, so we look at the digit after, the 4. This is less than 5, so we would round that down to 500. Then we can add them together. This is easier to add. The bigger the number that you're rounding to, so hundreds or thousands, then the easier your addition is going to be afterwards. So 3 times 5 is 8. So we've got 800, and we can still say, well, 800 is approximately equal to 809. So that's fine. So you only want to do one of these, but either would be fine. Then we've got question 10. The temperature in a flower cooler should be between 34 degrees and 36 degrees Fahrenheit. This line graph shows the temperature of a flower cooler last week. Right, okay, so let's have a look. So we've got, what have we got? We've got the temperature up here, we've got the days along the bottom, so we can see on Monday it was 34 degrees, Tuesday it was 35 degrees, then it goes up, comes down, goes back up for Saturday. Okay. Our question is, on which 2 days did the flower cooler not have the correct temperature? Well, we need it between 34 and 36 degrees. So if we'll keep this here, and I'm just going to remind us we want between 34 and 36 degrees. So we want which 2 days it did not have the correct temperature. Well, actually, what I'm going to do here is say, and I can just grab my ruler for this bit, I'm going to actually draw a line at 34 degrees. And draw a line at 36 degrees. Now, everything on those lines or in between is good. Anything outside we don't want. So we've got one up here, one down there. So if we read down from this, we've got Wednesday, and this one here, we've got Friday. So we can write our days in. Wednesday, Friday. And that's the end of the non-calculator section. Okay, so now we can start on the calculator section of the paper. Okay, so first question. Question 1. Work out 826 divided by 14. Well, before you start drawing a bus stop and trying to work it out, we can use our calculator. So, turn it on. 826 divided by 14, and we get 59. Okay, so do remember you can use your calculator for all of these. Now, it's not going to help with all the questions. Question 2. Now, a calculator's not going to help you on this one. Which one of these shapes has only one line of symmetry? Okay. Oops. Right. Well, let's start. Well, with a circle, if we know where the centre is, a circle's got loads of lines of symmetry. Because you could have one through the middle, like that. You could have one that way. In fact, with a circle, so long as the line's going through the middle and going all the way through it, you've got an infinite number of lines of symmetry. So it's not going to be A. Okay, so not that one. With B, well, this one we can see we've got 2 lines. Well, actually, we can check. Yeah, what's that? 3.2 centimeters. That one as well. So that means that these angles will be the same. So we've got a line of symmetry going straight through the middle. So it looks like it's probably going to be B. But let's check the others. C, have we got a line of symmetry here? Well, we've not got one through the middle, because if we fold it over, basically line of symmetry means we get an exact mirror image. If we drew a line down here, that wouldn't match to here. It would stick out. You could try doing one on the diagonal, but again, if you fold it on the diagonal, and you can actually try and do it, if we turn the paper over, you might be able to see through it if you try it at home. this is going to come over here. It's not going to match the picture. So it's not C. Now D, this one, you're probably thinking, oh, well, we've got a line of symmetry here. But we've also got a line of symmetry through here. And in fact, we might even have some more going this way as well, if it looks like it's a square. But it says there's only one line of symmetry, so it must be B. Okay, question 3. What is the next number in this sequence? Well, again, with these, the best thing to do is look at the difference between the numbers. So, how are we getting from 3.2 to 4.7? Well, let's think of it backwards. Let's think, if we've got 4.7 and we take away 3.2, then that means the difference is 1.5. Or in other words, it means that they're increasing by 1.5. Let's try the same with this. So we want to know the difference between the numbers, so we start with the bigger one, the 6.2, take away the smaller number, the 4.7, and we get 1.5 again. So that means we're adding on 1.5. So to follow that pattern, we're going to want to add on 1.5 again. So, well, actually, I'm going to clear that. I'll start with the 6.2 and then add on the 1.5 to get 7.7. If I'd kept the 1.5 in my calculator and added the 6.2, that would be fine as well, but it's just easier to show. We'll start with the number and then add the 1.5 on. Question 4. Florists use foam blocks for flower arranging. A floristry student plans to make a flower arrangement with foam blocks that do not have right angles. Right, do not have right angles. A website sells these foam blocks. So we've got lots of pictures here. And the question at the bottom says, tick the foam blocks the student can use. Okay. He wants ones that don't have any right angles. Okay, so if we've got any right angles, we're going to cross it out. Well, a right angle is going to be anything that's got a nice sharp corner. So it's not going to be that one. This is a circle or sphere. It's a 3D circle. Can't see any right angles, so that one looks good to me. I can see a right angle there straight away, so it's not that one. I can see another right angle here. I should show in that first one as well. There's at least one right angle, so it can't be that. This shape here, well, this is a cone, so we'd have a circle at the bottom, and then these lines are coming up at an angle, so that one looks all right to me. Got a right angle here. Now, it might not look exactly as a right angle because it's a 3D drawing of it. But I know that if this is a square at the front, that would be a right angle there, so we can't have that one. Then we've got another sphere, it's just smaller, so that's all right. Another cone, another cuboid, so that's going to have a right angle, another sphere, and another cone. Okay. Now we don't have to cross. I just find it easier to put the cross in because then I don't have to think about those pictures anymore. Okay. Another, oh, sorry, let's pull this down a bit so you can see. Another floristry student plans to make a flower arrangement in a vase. He must fill the vase with water between 7 centimetres and 10 centimetres deep. There's our picture of a vase. It doesn't quite fit on there. Draw a line on the vase to show how deep the water must be. Label how deep the water is. Give units with your answer. Okay, well, if this is the bottom of the vase, we want it between 7 and 10 centimetres. So I'm going to measure up. Well, actually, what we can do it this way, because you would measure up from the bottom. So we're starting from here. Remember, with a ruler, we don't start at the end of the ruler. We start from the 0 or where the numbers would start. Okay, this hasn't got a 0, but it would be this point here. So we've got 1, 2, 3, 4, 5, 6, 7. It's going to be there. 8, 9, 10 is up there. So if I was trying to be absolutely precise, I'd probably measure twice and then join them, but I'm pretty confident that my lines are horizontal. Okay, so it's basically got to be between those. So this is our 7 centimetre line, and that's our 10 centimetre line. And it then says the measuring instrument I used was we used one of these, which is a ruler. Question 5. A student wants to buy 14 roses. Roses are 67p each. How much does the student pay? Well, it's going to be 14 times 67. So 14 times 67, and that gives us 938. Now, important bit here, this is pence. So 938p. They want the answer in pounds. Well, I know there's 100 pence in a pound, so I can either divide this by 100, or we can think, well, I'm going to move my decimal point twice, so it's going to be the same as £9.38. Because we've got the pound sign, we don't need to put the p at the end. Right. Then we've got flower food helps to keep flowers stay fresh. A shop sells flower food powder in different weights. Write these weights in the correct order, starting with the smallest weight. All right, so we've got 11 grams, 9 kilograms, 1,000 grams, and 4 kilograms. So we've got different units, some are grams, some kilograms. So I'm going to turn them all into the same thing. So I know that we've got 1,000 grams in 1 kilogram. So if we've got 9 kilograms, well, it's going to be 9 lots of this. So it's going to be 9,000 grams. This one's already in grams. Now 4 kilograms, so 4 lots of this. So that's going to be 4,000 grams. So we want the smallest weight. So we're comparing 11, 9,000, 1,000 and 4,000. If it helps, you can write them on top of each other. Remember to line up the units though. So if we're doing 11, the 9,000, if I write it sort of backwards, it would be like that. 1,000. So we've got our units here, our tens here, hundreds, and that's our thousands, and then finally we've got 4,000. So the smallest number is clearly going to be the 11. So 11 grams. What's the next smallest? Well, they're all in thousands, so it's going to be the 1,000. So 1,000 grams. Next smallest, so actually let's label this one. That's the smallest. That was the next smallest. 4 is smaller than 9, so that will be next. And then that one. So the 4,000, but they didn't tell us 4,000, they told us 4 kilograms. So we can write 4 kilograms comes next. And finally, we've got our 9 kilograms. Question 6. Florist ribbon is sold in different widths. A florist has a delivery of ribbon. These are the widths she ordered. So we've got 24 millimeters, 1.6 centimeters, 10.2 centimeters, and 63 millimeters. She puts the ribbon in a cupboard in order of size, starting with the widest. In which order does she put the ribbon? Okay, so similar to before, we're going to need to do some conversion because some of these are in millimeters and some are in centimeters. So 2 in millimeters, 2 in centimeters. So we need to know how many millimeters are there in a centimeter. Now, if you can't remember, we've got our handy not calculator, it's a ruler. We've got 1 centimetre on here and it is split into 10 millimetres. So we know 10 millimetres equals 1 centimetre. So let's turn all of these into millimetres. So if we've got 1.6 centimetres, well, we're going to have more millimetres. So we're going to need to do our 1.6 times 10. Which is going to give us 16 millimetres. And 10.2 centimetres, again we're going to have 10 millimetres for every centimetre, so we times that by 10, and we're going to get 102 millimetres. She wants these in order starting with the widest, so we want the biggest number. So 24, 16, 102 and 63. You can line them up again, or with this one, I don't think I'll need to. 102 is bigger than any of the others, so that's going to be my first one. What's the next biggest number? 24, 16 or 63? It's going to be 63. Then 24 is bigger than 16. So we'll do them in that order. So number 1, we go to the original value they gave, so it was actually 10.2 centimetres. The second one they gave was 63 millimetres. The third one was 24 millimetres. And finally, it was our 1.6 centimetres. Okay. Now the florist wants to make some large bows like this. Each bow needs a length of ribbon measuring 3 metres. There are 250 metres of ribbon on one roll. She asks a trainee to work out how many lengths of ribbon she can cut from one roll and how much ribbon will be left over. What does the trainee tell her? Right, so this one, I'm actually going to do this without a calculator first of all, because I think it's probably easier that way, and it gives us a chance to practice our bust-up method. So what we're trying to do, actually, before I even do that, we're trying to say 250, and we want to divide that into 3 metre lengths. So the 250 goes in here, and we're going to divide the 3 into it. So we say, how many times does 3 go into 2? Well, 3 is bigger than 2, so it can't go in there, so I'll put a 0. And we can carry the 2 across. So how many times does 3 go into 25? Well, let's do our 3 times table. 3, 6, 9, 12, 15, 18, 21, 24, 27. That's too many, because we've only got 25, so it's 8 times. So that was up to 24. If we've got 25, well, that means we've got 1 left over. So we can carry that one there. Now we say, how many times does 3 go into 10? We've got 3, 6, 9. So that's 3 times and 1 left over. So remainder 1. Okay, so when we do it down here, we can say we've got 83 lengths of ribbon and 1 metre left over. Now the reason I did it using the bust-up method is because I think it's actually more complicated on a calculator. If you've got a simple calculator like this, then if you did 250 divided by 3, well, we'd get the 83 straight away. But then the rest of it, we're getting it as a decimal. So 0.33, so we're getting a third. So we could take away the 83 because we know that we've got 83 full lengths, and then we've got a third. A third of what? Well, it's a third of 3. So you can do that, but again with a simple calculator, it's just going to mean that you've got to round it. So it will work, you'll get there, but when you've got some nice numbers like this, I find it easy to actually do it manually. Another florist wants to make small bows for his floral display. He needs to cut a piece of ribbon this length for each small bow. So this is the length they've shown us here, and we've got a measuring tape alongside it. Okay. So what are they telling us? What length of ribbon does he need for a small bow? So in other words, it wants us to read it off here. Well, we can't see it, but this is the end of the ruler, so we can assume that this is, or measuring tape, so that's 0 there, and 1 would be there. So we've got to go up to here, and this is at 38, and it's centimetres. So we need to put, it says give units, so we need to put the centimetres as well. Okay. Question 7. A florist starts to complete a bill for a customer. The labour charge, so the amount of work they do, is £72. This is part of the bill. So the flowers, quite expensive, £375.42. The labour charge is blank at the moment. The delivery charge is £35. And we need to get the total cost. Complete the bill. Well, they've told us the labour is £72. So we can put it in. I'll put the zeros in because they put pence on this number for the delivery charge as well, so it's just being consistent. Well, if we need to complete it, the last thing we need is the total. So that means we need to add everything together. So 307, oh, that's a 2. £375.42. Add on £72. In my calculator, I don't need to put the 0.0. Add that on, and add on the £35 as well. Then we get £482.42. Okay. Now part B. The delivery driver needs to take the flowers to the customer's house. So we've got the florist here. The customer's house looks like it's... florist is up here. Customer's house is down here. In which direction is the customer's house? So they're using this line to show us. Well, they've started to draw a bit of a compass here. So we've got north. Best thing to do, let's fill in the other directions on the compass. Now, I always remember, never eat shredded wheat. Or you might remember it as north and south and east and west, however you want to do it. Now, if we look at this line, well, this line is coming down here. So it's halfway between east and south, but we always go with the north or south first. So in this case, it's the south. So we call this south east. Okay. Then we're told the journey to the customer's house will take 45 minutes. The clock shows the time when the driver sets off in the morning. So 8:23. She thinks she will arrive by 9 o'clock. Is the delivery driver correct? Give a reason for your answer. Use AM or PM. Right, so we're starting at 8:23. And we want to add on 45 minutes. Well, if we're going to add these on, 3 plus 5 is 8. 2 plus 4 is 6. Well, if we do it like that, 868. You can't have 68 because the most you can have in an hour is 60 minutes. So this has actually gone over 60 minutes by 8 minutes. So in other words, the time is 9:08. And it's still going to be in the morning. So 9:08 a.m. So she thinks she'll arrive by 9 o'clock. No, she won't. So is delivery driver right? No. And our reason, she won't arrive until 9:08 a.m. Okay. Question 8. A florist offers a same-day delivery service for orders made in the morning. The manager keeps a record of different types of flower arrangements ordered in the morning. She makes this tally chart. So we've got a vase arrangement. We've got 19. Well, let's just check how they get that from the tally. So if you remember, each of these ones here, it's 1, 2, 3, 4, 5. So we're counting in fives. So 5, another 5, another 5, 1, 2, 3, 4. So 5 plus 5 is 10, plus 5 is 15, plus 4 is 19. Great. So we've got our vase arrangement, we've got our bouquets or bouquets, and we've got a posy. Complete the totals in the chart. Right, so a bit like we did for the vase, we need to do the same for these two. So that's another 5, and another 5, and another 5. 5 and 5 is 10, and 5 is 15. Here we've got 5, and another 5, and 1, 2, 3. So 5 and 5 is 10, plus 3 is 13. And you can use your calculator to help with the addition if you want to. Okay. And she wants to know the flower arrangement with the most orders. So we're looking at which is the biggest number. Well, the biggest number is 19, and that's the vase. So we can put that in there. Okay. The florist had some more orders in the afternoon. These are the number of orders in the afternoon. So there were 9 for vase arrangements, 11 for bouquets, 12 for posies. The manager thinks the posy flower arrangement has had the most total orders at the end of the day. Oh, that's down here. Is she right? Give a reason for your answer. Use numbers to help you. Right, so what we need to do is add in the numbers we had from before. So let's go back. So for the vase, we had 9, or we had 19 originally. For bouquet, we had 15. And for posies, we had 13. Okay, so we want to add these on. And we can say these are our totals. So 9 plus 19 gives us 28. 11 plus 15 gives us 26. And 12 plus 13 gives us 25. Okay, she thinks the posy has the most total. Well, no, the vase has the most. So, is she right? No, she's not right. And we can say, because there are, and we can say 28 vase arrangements, 26 bouquets, and only 25 posies in total. Something along those lines. Question 9. A student needs to work out the cost to make a floral arrangement for a customer. He has to add a labour charge to the cost. The labour charge is 1/4 of the cost of the materials for the flower arrangement. The cost of the materials for the flower arrangement is £132. How much does he charge the customer? Okay, so we've got the original amount, and then we've got the labour charge. So the original amount is 132. The labour charge is 1/4 of the original. So 1/4, we're going to want 132. Dividing that by 4 to get a quarter. So 132 divided by 4, that gives us 33. So if we add on the 33, well, we've already got the 33, so let's keep that and add on the 132. And we get £165. Okay. Now we've got the final question. The manager of a florist shop needs to draw a bar chart to show how many gifts they sold last month. So balloons, there were 400 sold, chocolates 350 sold, and soft drinks 250 sold. Draw a bar chart to show this information. Put labels on your chart. Okay. So we've got to think about which way we want to do the bars. They can go across, but normally we would have the bars going up. So I'm going to do mine going up. Now, we've got balloons, chocolates and soft toys. So we've got 3 categories here. So I'm going to think, how many squares do we want for each category? Well, if I'm going to start my chart here, so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we could work it out. We could have 3 for each category. So we could have 1, 2, 3, 1, 2, 3, 1, 2, 3. Or maybe we can make it bigger. Let's see if we do 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Yeah, so that works. So I'm going to mark that out. At the bottom there. So we're going to have, and I'm just going to keep everything in the order that they've given it to me. Balloons, chocolates, and soft toys. And we need a label for these things. So these are all gifts. Now we've got to work out what numbers we're going to have going up the side. So we want to look at what the biggest number is, because we need to go at least as big as the biggest one, which is 400. So what are each of these squares going to be worth? Well, we could make them 100 each. 1, 2, 3, 4. But then our graph would be pretty small. Be just down here. So maybe instead of 100, what about if we make them 50 each? So 50, 100 would go there, 150, 200 would go there, 250, 300 there, 350, 400. So that uses up a better part of the graph paper. So really what you want to be trying to use is at least half of the graph paper. Okay. You will notice that I've not written all the 50s on there. You can if you want to, but you don't have to with a graph. You can miss some bits out. So let's check the numbers. Balloons, 400 were sold. So we go up to 400 and we want to draw a line all the way across. Chocolates, 350 were sold. Well, 350 is going to be halfway between the two. So we just find where chocolates are. Draw that one there. And for soft toys, 250 were sold. So that's going to be halfway between 200 and 300. So we need to go across to soft toys. So it's going to be from here to here. And then we can draw these down. Now your bars don't have to touch, but I just find it's easier if they do touch, because then you don't have to draw so many lines. Now the only thing that's missing from our graph is a title. So we can just put Florist Gifts. There you go. And that's the end of the paper. So I hope you found that helpful. Please like, subscribe, make sure your notifications are turned on so you get updated when I load more videos, and hope to see you again soon. Thank you.